A quick review of last Thursday is basically the formulas are very similar because they all have cosine in them. But for example, if you're going to take half of the angle and take sine, it's 1 minus cosine over 2 and take the square root. If it's cosine, you add it, and then tangent is a combination of the two. These examples right here where the angle was given specifically, we talked about on Thursday. Now we're going to take a look at, well, what happens if they just give me various information. So here it says if sine of A, so there is an angle A out there somewhere, equals 3/5. So before we even keep reading to find out where A is, we know A has to be in one of two quadrants because it's positive. So it has to either be in quadrant 1 or 2. It has to be. And it ends up that A is actually in the first quadrant. They would like me then to calculate each of the following values. So they want me to take whatever A is, divide it by 2, and find sine there. So what we need to do then is go ahead and say, all right, well, the formula then says plus or minus the square root of, and for sine, what does the formula say? How does it read? Yes, Ms. Piper. Okay, very good. And in this case, instead of x, we'll probably write A, just because that's what it is. We'll just replace it. Now keep in mind, this is saying take A and cut it in half before you take sine. This A that's inside is referring to the exact same A as right there, agreed? And we know that A that's up top is in the first quadrant. Do we know exactly where? No, we could. Right? We could figure that out. But again, I'm trying to do this more in general. And so if sine is 3/5, you're probably getting used to drawing these pictures if we're not given the angle because the picture represents the angle. And so we've got a 3 and a 5. Where does the 3 go? If this is angle A, 3 would go opposite, and the 5 is then hypotenuse, leaving us with what? 4. Positive 4, negative 4, positive 4. Okay. Obviously, if it was second quadrant, that would have been a negative 4. And so now we can go back to the formula. 1 minus. Now, if we could figure out what cosine of A was, we can completely replace cosine of A with what fraction it is or what decimal it is, depending on how you want to do it. But normally we do fractions in this case. Do we know cosine of A, or can we figure it out? Yeah, we can figure it out. And if we look at our picture, that's of angle A, correct? And what is cosine of that picture? 4/5, because it's adjacent over hypotenuse. So you are correct, 4/5. But we can't forget that all of this has to be divided by 2. Any suggestions at this time? Yes. Now, why is 5/5 what we're going to change it to? Yeah, it's just going to help us. And you're starting to get used to that. Whenever we don't have a fraction on either the top or the bottom, I'm having you do that. And you should get very, very used to that. So we got positive, negative. Now, when you have a common denominator, you do 5 minus 4 is over 5. Very good. All over, again, that's kind of the one you would make a little darker. 2. Now, some people would actually write a little bit more there. They would write 1/5 and then the big fraction bar, and then some people like to see 2/1 there because then they know. But really, let's face it, dividing by 2 is the same as multiplying by 1/2, so it works out the same. So we got a 1/5, which we're really going to take times 1/2. Is everybody okay how the 2 came up and became 1/2 like that? Now, that's not a common denominator. Is that okay? Yeah, it's multiplying. It doesn't matter. So it's the square root of. Well, this is advanced math. You're not quite to calculus yet, so you can't necessarily leave stuff like that. But when it's division like that, what can we do with radicals? Not quite flip them. But we can take we can do the top and bottom separate. I was kind of hoping somebody would mention something by now, but I'll just keep writing them. Yeah, well, we'll see if anybody can give me a good suggestion on what to do there. Why not? How do you know that? No, A is in the first quadrant, not A/2. How do you know that? Yeah, for example, if you're at 89 degrees, that would have started us in the first quadrant, correct? If I take half of that, am I still in the first quadrant? What if I say 1 degree? I take half of it. Am I still in the first quadrant? So can we actually get rid of the plus minus and just know at this point that it must be plus? Because it's going to stay in the first quadrant. It's not going anywhere. Now, do they always stay in the quadrant? No. Well, how about the square root of 1? That is? Over? Oh, yeah, unfortunately, you're not quite to calculus yet. So, yeah. And what's this called again? Okay, we call it the funny form of 1. It is called the conjugate, technically. Square root of 10 over. And you're sure it's positive? Because yes. Now, what if I would have started in the second quadrant? It would have still gone back to the first, because any angle in the second quadrant, if you take half of it, you end up in the first. Okay? Now, we know that sine of a over 2 is square root of 10 over 10. Last time we had something similar to this, I went to this problem like this, and we went right through the formula again and did all the work again. Does anybody have a suggestion that could possibly stop us from having to do that? If not, we will just do that. Can we make a new picture? Do we know exactly where a over 2, or which quadrant a over 2 is going to end up in? It's got to be in the first, doesn't it? So can't I draw a picture for a over 2? Well, let's do that. That's what I would do. It's kind of a cheat, but... So there's a over 2. We know that a over 2, so sine of a over 2 is this right here. So a over 2 is actually now the angle. I know sine is square root of 10 over 10. So sine of my angle a over 2 is square root of 10 over 10. Does that help me draw a new picture? Yeah, big time. And it saves you a ton of time. For example, where does the square root of 10 have to go? Opposite. And the 10 then goes hypotenuse. So this is obviously not one of the triples that we're necessarily going to know right away. You want me to just call this maybe x? So it's x squared plus the square root of 10 squared equals 10 squared. Why am I doing this? Yeah, I got to find the other side. It's kind of the Pythagorean identity. It's very similar. So it's x squared plus, well, what is the square root of 10 squared? Okay, well, you're a little ahead of me there. Subtract 10. X squared equals 90. And how are we going to deal with x squared equaling 90? Now, technically, it's plus or minus. Which one is it based on our picture? Plus. And square root of 90. Do you think I will allow you to leave it as the square root of 90? How can you break down 90? Again, you want one you actually know the square root of. 9, okay, and 10. Square root of 9 is? Can you do anything with the square root of 10? Not that's helpful. So this is 3 square root of 10. Yeah, algebra 2, just come on back. At this point, though, can you tell me cosine based on that picture? Okay, what is it? And what was something I was very nice that I didn't do in this particular case? I didn't put the radical on the bottom. So yes, you take adjacent, which is 3 square root of 10 over 10. Would the formula still have worked? Yeah, it would have worked just fine. And really, in this case, would you really have saved all that much time doing it this way? Not really. But where it could definitely save you time is on the next one. Just look at tangent's formula again, right? There's a lot of stuff going on there, right? You'd have to get a common denominator on top and bottom, be a big pain in the butt. But now we have this picture. Again, this picture is of a over 2, not the original, but a over 2. Can we now figure out tangent? Tangent is sine. Well, you could do it that way, or just opposite over adjacent, because we have the picture. Opposite is over. Now, some people get upset with me that I put a radical on the bottom, but they fail to realize that they cancel. But then, very good. There's a understood 1 there. So it is just 1/3. Could you have taken sine's answer and divided it by cosine's answer? Yes, you could have. But the way you decided to do these problems, it was way faster just to look at our half angle. Okay. The key is finding out where these angles end up. Do they end up in the first quadrant, second? Once you do that, it's pretty simple. Any questions?